program is brought to you by the Ministry of Education and Vocational Training Zanzibar, funded by UNICEF. Production expertise produced by Kwarara Media Education Center, KMEC, under the supervision of Department of Teacher Education, DTE.
Hello, my dear students. How are you?
We are fine.
I'm quite well. Welcome to the physics lesson. So today we are going to learn about the optical instrument. So from our optical instrument, we are going to concentrate on the three important things. The first one, we have the structure. The second one is the mode of action. And lastly, is the uses of the optical instrument. But we have to focus only one optical instrument. Are you ready?
Yes.
Okay, so clap for yourself. Okay, thank you. Now, in front of you, we have some questions that we are required to discuss together. Okay, so we have only 1 minute for that question, please. So you can discuss even with your fellow student, please. Okay. Yes, it is nearly a time. Who is ready? Yes, Fatma.
Astronomy is a branch of physics which deals with heavenly body in space.
Okay, now all of you.
Astronomy is a branch of physics which deals with heavenly body in space.
Okay, so here we have that answer. Astronomy is the branch of physics which deals with the heavenly bodies in the space. Okay, so clap for Fatma, please. Okay, now let's move on with the second question. Is there any difference between simple microscope and compound microscope? Also, I will give you 1 minute, please. Yes. Who is ready, please? Yes, Juma?
Simple microscope defines seeing that is smallest, but compound microscope defines things so hard.
Okay, well, thank you. Another one, please. Yes, Asha?
Simple microscope magnifies far C, but compound microscope magnifies nearer C.
Okay, thank you. Well, okay, now clap for them. Okay, so here, let us see, we have the simple microscope. Simple microscope is just a simple glass. That is a convex lens. Now all of you say convex lens.
Convex lens.
Of course, we are familiar, even in biology, in the branch of classification of the plants and some animals, mostly the small object, right? Yes. Now let us see for the compound microscope. All of you say compound microscope.
Compound microscope.
Yeah, there we have the compound microscope. So if we cross-check from those two diagrams, we can see that here we have only one convex lens, but here we have the convex lens here and another one was found there. So simple microscope use only one lens, right?
Yes.
And the compound microscope uses two lenses, right?
Yes.
Okay, then we have that optical instrument. We have that optical instrument. Now, through your pair, I need the answer for that. What is the name given to that instrument? What is the name given to that instrument? Hussein, please.
The name of that instrument is called telescope.
The name of that instrument is called, now all of you?
Telescope.
The name of that instrument is called as?
Telescope.
Right. Thank you. Clap for yourself. Okay. So that is the optical instrument which is called as astronomical telescope. Now all of you say astronomical telescope.
Astronomical telescope.
Astronomical telescope, first of all, is an optical instrument because it uses light to perform its application, right? So, is an optical instrument designed for observing distant celestial objects such as stars from the sky. We have the planets. Then we have galaxy, of course, just the collection of stars in the sky, and then other astronomical phenomena. So that is called as astronomical telescope. Again?
Astronomical telescope.
Okay, well, good. Clap for yourself. Yes, now we are going to learn about the structure of the optical instrument, which is astronomical telescope. Now we have the principal features of the astronomical telescope. So there, astronomical telescope uses two convex lenses. As we have said earlier that we have seen for the simple microscope and compound microscope. Simple microscope only use one. Okay, so if that is the case, here we have two convex lenses. The first one is called as objective lens, and the second one we have the eyepiece lens. So this is called as astronomical telescope. The first one we have said we have what? Objective lens. So objective lens is found from here, right? Yes. Whereby the object is being viewed. Then the second one is the eyepiece. This one is called as eyepiece. Normally, the objective lens has a large focal length, while the eyepiece has a much shorter focal length. Of course, we can see the difference between the astronomical telescope and the compound microscope through their focal lengths. So these lenses, I mean objective lens and eyepiece lens, are connected together using a cylindrical tube. So the shape of this piece is the cylindrical tube. Now all of you say cylindrical tube.
Cylindrical tube.
Again?
Cylindrical tube.
Okay, then after that we have the stand. So this is the stand, and our telescope is ready for use under normal adjustment. So we have this that we can adjust the distance viewed, the distant object viewed maybe from the sky like a star and other objects. Then we are going to view from the eyepiece, right?
Yes.
Do you understand?
Yes.
Are you ready to mention one piece after another? Yes. Are you ready to mention?
Yes.
Really? Okay. So there, we have different numbers. We have number 1, number 2, number 3, number 4, number 5. Who is ready for number 1? Yes, there, please.
Eyepiece lens.
Eyepiece lens, that number 1. Is that okay?
Yes.
Number 1 is
Eyepiece lens.
eyepiece lens. Oh, wow, thanks, clap for her. Okay, who is ready for number 2? Namshwena?
Objective lens. Objective lens.
Objective lens. Is she right? Yes. Really? Yes. Let us see for ourselves. Okay, objective lens. Clap for her. Who is ready for number 3? Number 3 is the tripod stand, because we have the first, the second and third. That's why it's a triple stand. Okay, now let us see. That is the stand to simplify the move, isn't it? Yeah. Okay, now we are moving to number 4. Number 4, please. Cylindrical tube. Now all of you?
Cylindrical tube.
Yes?
Cylindrical tube.
Cylindrical?
Tube.
Okay, think now let us see. Cylindrical tube. Okay, the last one. The last one, number 5. The last one, number 5. Okay.
Focusing knob. Focusing knob.
Focusing knob. Yes, that's good. Focusing knob. To focus means to adjust. All right? Yes. Focusing means to adjust. So here we have the focusing ring. This one. That's why it's moving inside and moving outside. That's why it's called as focusing or adjusting rings. Right? Yes. Okay, well. So number 5 is the adjustment rings or focusing ring. If you are interested to view the distant object, so in order for that distant object to be cleared, so we have to focus. That is like a camera. You have the focusing ring, right? Yes. Okay, clap for yourself. Do you have any question until to that point? Okay, now my dear student, we have to discuss together about the mode of action that we can call just a ray diagram of the astronomical telescope that will help us to describe or to discuss about the mode of action of the astronomical telescope. Okay, so in front of you, we have the mode, we have the diagram, or we can call as optical ray diagram of the astronomical telescope. As we have said earlier that here we have mentioned all the important parts of our telescope. All right? So we are going to start with the rays from the distant object. So suppose we want to view the mango tree outside of our class. So the first thing, we have the light which is entering into our instrument. So that's why we can say rays from the distant object. After that we have this objective lens. We have that objective lens, right? So objective lens is found from here, which collect the rays from the distant objects. After that, what next? Then we expect to have the image formed because this convex lens converge those rays to this point Q1, right? So here we have the image formed. That image is small compared to the size of the distant object. So after that, eyepiece, this image will act as an object for the eyepiece. Will act as an object for the eyepiece. Then here, what is this? Eye. Eye is found from human being, right? Yeah. So that human being we can call as an observer. All of you say observer. Observer. Again? Observer. Okay, so observer through the eyepiece here is going to view through the eyepiece lens here. Then inside our instrument we can observe the final image. So even the star, which is the distant object, found distance apart from our instrument, but we can see the final image formed, right? So if you compare the size of the first image, which is the object for the eyepiece lens, then we have the final image. So this final image will be observed by the observer here through the eye lens, right? Yes. So after that, we are interested to know the characteristic or the nature of this image formed. So if you compare the size of the image and the size of the first image, do you have anything to say on that point? Which is bigger? Which is larger? The first image, the second image? The second image, isn't it? So thus, here, we expect to have the result for that. The first, we have the virtual image. Why is called as virtual image? Who can try? The virtual image, instead of having real image. Virtual image, okay, come on. Yes?
Because it is not real image.
Yeah, because it's not a real image, that's why it's called virtual. So thanks for that. Okay, clap for him, please. Okay, this image is called virtual because it's found behind the lens. Is found behind the lens. That is just the same like a plain mirror, right? In your dressing table. So you can see the image inside the plain mirror. That is called as a virtual image, right? Yes. Are you clear? Yes. Okay, and the second one, we are going to compare about the size of the first image and the size of the second image. Up to that point, here, this is called as inverted. Why inverted? Because the object is found here from this principal axis and the image is found here. That is opposite. That is the second side of this line, right? So that's why it's called as an inverted image. Like you, if you are interested to know the last, here we have the magnified image. Why is called as magnified? Because the size of the image, the second image, is greater than the size of the first image. Where the first image will act as an object for the eyepiece lens. Now, my dear students, do you have any question? Thank you. So, this is the working principle of the astronomical telescope. And this diagram is called as a well-labeled diagram of the optical arrangement of the astronomical telescope. That is the optical ray diagram, right?
Yes.
Are we together?
Yes.
Okay, so first we have the structure, then we were concerning on the mode of action of the astronomical telescope. I hope you can explain, you can describe the mode of action of the astronomical telescope, right?
Yes.
Now, we have to move to the magnification. That is a very important term in optical instrument. As we have said earlier here, we have the magnified image. We have the magnified image. That's why we are going to concentrate on the size of the object and the size of the image. So if the size of the image is larger compared to the size of the object, then we can say that the image is magnified. But opposite to that, when the size of the image is smaller compared to the size of the object, then the image, we can say, is diminished. Now all of you say diminished.
Diminished.
Again?
Diminished.
D. That is? Diminished. Now all of you?
Diminished.
Diminished is the opposite of the magnified for the image, right? Okay. So when we are saying magnification of the astronomical telescope, we mean that we have to compare the size of the object and the size of the image found from the telescope, right? Yes. So basically, we can say that magnification is the ratio of the height of the image to the height of the object. Now say magnification of the astronomical telescope.
Magnification of the astronomical telescope.
Okay, by definition, we can say that magnification is the ratio of the height of the image to the height of the object. Now, all of you, what is magnification?
Magnification is the ratio of the height of the image to the height of the object.
Okay, so that statement can be written mathematically as M is equal to H over H naught. M is equal to H over H naught. Now, all of you?
M is equal to H over H naught.
Okay, now clap for yourself. Okay, now this is the general term that magnification is the ratio of the height of the image to the height of the object. So for the case of the astronomical telescope, we can say that magnification is the ratio of the focal length of the objective lens to that of the eyepiece lens. Did you remember about objective lens?
Yes.
Eye lens?
Yes.
Okay, so this also can be treated mathematically as M is equal to F naught over Fe. Now all of you, M is equal to?
M is equal to
F naught
F naught
over Fe.
over Fe,
Where M stands for magnification, and F naught stands for focal length of the objective lens, and Fe is the eyepiece lens. Can you remember that formula, please? Can you write for yourself? Yes. Okay, write it down in your paper, please. Write that formula. M is equal to H over H naught, and M is equal to F naught over Fe. Are you ready?
Yes.
Who will tell us M stand for what? Yes? M stand for magnification. Thank you. Sit down. Okay, now F naught. Yes?
F naught is equal to focal length over object length.
Focal length of the objective lens. Thank you. The last one, FE, please. Yes?
Eyepiece lens.
Eyepiece lens. But you have to say that the focal length of the eye. Okay, clap for yourself. Are you ready to do some exercise?
Yes.
Before exercise, we have to see what? Okay, now read aloud that example, please. 1, 2, 3. Okay, thank you. Good. Telescope. A telescope of an objective lens of focal length 100 centimeters and an eyepiece lens of focal length 2 centimeters. What is the magnification? Okay, the next step we have to produce the given. How many givens are there?
There are 2 giving.
Okay, the first one. The first one is focal length of the and the second one. Okay, now let us see. Yeah, it is giving that focal length of the objective lens equals to 100 centimeters and focal length of the eyepiece lens is 2 centimeters. Okay, according to our giving, magnification is equal to what? Yes?
F naught over Fe.
F naught over Fe. Okay. Then what is the value of F naught? Yes?
100 centimeter.
100 centimeters. What is the value of Fe? Yes?
2 centimeter.
2 centimeters. Can we cancel it? Yes. Okay. Centimeter and centimeter cancelled out. Then how many 2's in 2? 1. How many 2's in 10? 5. How many 2's in 0? 0. So magnification is equal to what? 50. So the magnification of that telescope is equal to 50. Are we okay? Yes. Okay, clap for yourself, please. Okay, now it is your time for the exercise. Are you ready? Yes. Can you take out your book, please? Just read, please. 1, 2, 3. Okay, thank you. Now we have number 2. And lastly, we have number 3. Yes. That is the optical arrangement of the astronomical telescope. And that's why this is your homework exercise. Are you ready for that? Yes. Okay. So until next time, goodbye. Bye. Okay, thank you.